All right, welcome everyone to the 10th episode of Game Dev Insiders. I'm Justin, and then I have Santiago with me. So if we started I ended the last episode back in October. I said that we would do another episode when I finished the sample scenes. It took a little bit more time than I expected, but the sample scenes for Behavior Designer Pro are done. And I'm excited to kind of show them off now. They took a whole lot longer than what I was expecting. I was really thinking that, we would do another episode in November before the holidays and all that, but that obviously didn't happen. It's February now. So my estimate was a little off, but these sample scenes have been really, really good at kind of going through the paces with Behavior Designer, fixing bugs, polishing the asset, and just actually we're going to be using a lot of them for marketing material as well. So they've been really good in that sense. It's just taking a lot longer, but I am done with the sample scenes now. Santiago has played with Behavior Designer Pro. He has not seen these sample scenes yet, so we're going to see what he thinks of them. And if he wants to be part of Optiv, he's going to have to be positive in the future.
I see positive reviews. Okay, I'll do that.
Right, yeah. So before we get started, let me just show you where we came from, because I think that's a really good kind of comparison to show how new these sample scenes are and how helpful they will be. So let me go ahead and share my screen. So you should be able to see my screen now. And in Behavior Designer 1, we had 3 or 4 different main sample scenes. I think this was the last sample scene that I created for Behavior Designer 1, and it was a utility theory sample. Let me go ahead and hit play. And this utility theory sample would just kind of show using a utility value between eating, working, and sleeping. And so if I look at the behavior tree, you can see that the behavior tree is a fairly simple behavior tree. And you see Ethan, he's not animated. He's just kind of going through the motions of, oh, now I'm going to this section, now I'm going to that section. And in the log, you can see the utility value for each of the branches. So yeah, that was the utility sample. This was probably our most extensive sample that we have for Behavior Designer, which was a pretty low bar. So the other sample scenes that we had was, I think this one was one of the first sample scenes that I came up with before Behavior Designer 1 was released. And it was just a little sample scene showing these bots kind of moving around. Oh, and I don't have the nav mesh baked. Well, I'm sure you've seen it. The sample scene, yeah, these bots can go around and they can attack each other. They eventually get the flag. Actually, let's see, is this quick to AI navigation? Oh, yeah, it's a new nav mesh. Okay, yeah, whatever. Old sample scene. Let's see if this RTS scene will work. I don't have this nav mesh baked either, probably.
This guy has the same problem, probably.
Yeah, okay, wait. So I know Unity switched up their nav mesh, and I think it may have been the problem. Oh, it's what's probably happening is that I'm using a newer Unity version, then they switched their nav mesh package to the packages version, and this was using the baked in version. So now I need to set that up again. So let me just go ahead and nav mesh surface, bake that real quick. Okay, so now I will, now that I've noticed this, I will update the sample scenes for Behavior Designer 1 to make sure that they work. Because Behavior Designer 1 is still supported, and it will still be supported. Behavior Designer Pro is coming out, but I am still going to support Behavior Designer 1 because Behavior Designer 1 does have its use cases, especially since a lot of people are currently using Behavior Designer 1. So I'm definitely not going to drop support for that. So yeah, I'll make sure these sample scenes now have the right nav mesh. But yeah, so this sample scene was actually, I kind of like the sample scene. It was kind of an RTS example, showing these harvesters kind of getting ore in this case, and they're just going through the different ore fields. And then you can create some units with the money that or the gold that I guess the sky cars have harvested, and then those units can attack the different targets. So this was I mean, graphically, it was a terrible sample scenes, but from a behavior designer perspective, it actually worked pretty well. Um, let's see. Now that I know the little trick for baking, let me go ahead and show this capture the flag one real quick too. Let's see. Where do I have the floor? There's the floor, nav mesh surface. Okay, now we should be good. So these little blue bots, it's kind of hard to see in my small screen. Let's see. The blue bots are right here, and they will be trying to capture the flag, and then the red bots are chasing them and trying to kind of let's see, they're trying to just stop the blue bots from getting the flag. So that was a neat sample scene as well. And then the last sample scene was what I called mini gauntlet, and it was basically you had Teddy the bear. He would be going around and just reacting to different triggers and whatnot within the behavior tree. This was a little bit later of a sample scene as well. And it was actually, it looks like I have a custom decorator here showing it off, but yeah, so these sample scenes are pretty basic. Not much thought or not much art thought went into them, but they serve their purpose. So that was Behavior Designer 1. Behavior Designer 2 has been a completely different beast. For the goal of these sample scenes, I wanted to show a specific feature as well as kind of show some marketing material. So if we remember the Behavior Designer 1 sample scene with the utility theory one, we had an agent that was switching between work, eat, sleep. And we now have this, which is the same thing, except it looks a little bit better. So from the behavior tree perspective, it's very, very similar. Actually, this tree is very similar, yeah. There's a little bit of difference in that now we have node groups, so that's cool. We can kind of group everything in. And then when I hit play, this utility curve evaluator will show you the value on the task, so that will work. But from the sample scene perspective, we actually have animations. There's a little bit of polish still needed, whatnot, but we actually have kind of the actual kind of agent moving around, working, eating, and sleeping. So this is the sample scene for the utility theory, and yeah, it's just a whole lot more polished compared to what we did for the version 1, and I liked his sleeping animation.
It is very nice. I do very much enjoy the values that you see directly inside the editor. They're so useful for debugging things and for actually understanding what's happening at any time.
Right. Yeah. In this case, let me go ahead and pause this. So actually, I'll pause this after he's sitting down, or no, it's work. So after he starts typing. So he's typing now, and kind of on the behavior tree, we have two different values that will live update. There's one on the utility curve evaluator. This is the utility function for this branch, and this will update every frame. And then there's also the wait task. This was actually a request from you, Santiago, to show kind of a slider of how much time has elapsed for wait. And so yeah, this is a live view, kind of allowing you to debug it in real time. So yeah. It looks like Atlas is floating right now, so it looks like I have some animation issues. This will be fixed before we release.
That's why we have those live sessions.
Right. So that's the first sample scene. I guess I didn't say this, but if anybody has any questions, feel free to go ahead and ask in the chat. I will go ahead and respond when I see it. I do have the chat open on the other screen, so I will be able to respond, or Santiago will be able to respond. So this sample scene was completely dedicated to showing the utility theory. One of the questions that I got asked pretty often was, how do you sync your animation with the behavior tree without actually kind of using behavior tree nodes to sync your animation? So for example, instead of me saying, oh, set float or set integer 5 within the state machine or the animator controller. I instead wanted to do it automatically for me. And there's a way that you can kind of synchronize state between the nav mesh agent in this case and the animator controller. And actually, if I it's a simple behavior tree. This agent is just patrolling, and there's no animation synchronization at all within the behavior tree, but it's just a separate component that's doing the synchronization. If you're using our character controller, you don't have to worry about that at all, but this is just a specific example showing how you can synchronize it, just because I got a lot of questions about related to this, not necessarily because it is anything difficult within Behavior Designer. This synchronization component doesn't even know anything about Behavior Designer. So it's just a really clean way to keep your state, your character movement synchronized with your animator controller. So that was definitely a more basic example. Let's see, the next one is a fairly basic example as well, using conditional aborts. Conditional aborts are a major topic in Behavior Designer, major feature in Behavior Designer. So I wanted to kind of show the classic use case that I actually think in the Behavior Designer tutorials, I have something similar. So yeah, this abort scene is just pretty much exactly what you would expect. We just have two different behavior trees. One has a lower priority abort, just showing how that is done. I will be doing a tutorial series on Behavior Designer, and we'll be specifically talking about conditional aborts. That video will look very similar to the one that is out in Behavior Designer 1, because the concept really hasn't changed at all. There's one additional feature, but besides that, this pro version is very similar to version 1. All right, let's get to some more. I'm going to save the entities one for last. Event branches. So event branches are a new thing in Behavior Designer Pro, and what it does is it allows you to have different entries into the behavior tree. So you can see we have this start node, which was what we had in version 1 of Behavior Designer. It was called the entry node. And now what we have are different starting or entry, or what do we call them, event nodes for like on trigger enter. There's an on trigger exit. If I right click, create node, and I go to branch events, you can see there's a decent number of included branches. So this one is actually extremely useful for conditional aborts, where let's just say that, actually, let me go back to this other scene real quick. He'll help me demonstrate it a little bit more. So with conditional aborts, in the past, if idle was active, like it will be right now, and you wanted to kind of clean up your animation after idle ended when an abort occurred, there wasn't really a good way to do it. You'd have to, let's just say that idle was playing, I don't know, what, some type of animation, and then an abort occurred, and then you would want to stop that animation or play some animation event to clean it up. Well, with conditional aborts, they happen instantly, and in the behavior tree, there wasn't a way to kind of say, oh, I want to run this kind of cleanup branch. Well, now with this, I was typing cleanup, with this interrupt branch, what you can do is you can say, anytime that can see object is interrupted, I want to, I don't know, we'll just say we'll log a message in this case. And so now this message will be logged, which in this case is not very particularly useful, but these event branches allow you to clean stuff up so that instead of logging a message, you could say, oh, well, change this setting back to its default value, or stop this animation. So these, event branches make that part extremely easy to do. And this scene right here is an example of using various event branches to trigger different functionality. So it's kind of a 2.5D-ish scene, similar to Mario, kind of very basic, but we have like the coin. He just collected a coin, and it was through this on trigger enter where, okay, we increment some count, and then we disable the coin collider. And that would allow, actually, let me, so you can see here within the interrupt, this is a dynamic variable, and I named it coin collider. So now when I disable this game object, the collider name is coin collider. So that will prevent I guess it would prevent, or it would disable the coin game object. So that's how it disappeared. So yeah, these branches allow you to kind of have dynamic functionality outside of the main behavior tree branch. The jump branch in this case will jump when it enters a trigger, and then it will set some animation event or animation state, and then it will also add a force to the rigid body, and then it will disable that animation state as soon as the character leaves the trigger. So it's a very kind of specific example for this scene, but it does a good showcase of showing, okay, now these different events are occurring, and yeah, so you can kind of have specific functionality depending on what occurs.
So I have a question about those events.
Yeah.
These events did not exist in Behavior Designer 1, correct?
Correct. These event branches, right?
Yes. And can you specify like what it's like the event trigger, what the target is? Because I saw that in the previous example, you could select a specific node. In here, they're connected to the game object that you're on. Is that correct?
That is correct. Yeah. So it depends on which event node you're referring to, but yeah, let's see. There's also another event would be, so these physics ones, they are tied to the specific game object that you're on, but that's a fairly easy change, or a really easy change, to make it so that it accepts a different type of game object instead of your exact one. And with that, yeah, let's see, there's a on received event. I think this on received event, no, okay, so yeah, I will add in the functionality so that you can specify a game object, because that would be extremely useful.
Yeah.
I do that with, let's see, like this set float. There's this target. So if you set it to none or null, then it will use the current game object value. But you can also set it to anything else. So that's extremely similar to what you were just describing for these event branches or these event nodes.
Yeah, I think that makes complete sense. It's super cool to have those events because it can simplify certain things so much.
Right. Oh yeah. And the cleanup one or the interrupt one, I think, is going to be the most used one out of anything. Just because, I mean, like within Deathmatch AI Kit and within like the character controller integration, having this interrupt node would clean up so many branches or so many tasks of, oh, now I need to reset this. So yeah, I think actually within Deathmatch AI Kit we have a specific task called reset, specifically because these event nodes didn't exist in version 1 of Behavior Designer. So yeah, it will be a good feature. Let's see. Oh yeah, okay. So I like this scene. It looks simple, but it's a lot of fun. For this one, it's called events, and we are showing the event use case of sending and receiving events. So let me go ahead and actually, before I show the behavior tree, I'm just go ahead and hit play. And what we have happening is a turret shooting a whole bunch of different characters, and then there's this medic guy who has to go revive them, and it's using events to kind of have this medic go between the different players. So yeah, we just have a horde of agents running down, and the medic has to go clean them all up.
That's pretty brutal. I like it.
Yeah, this was a fun scene. Let's see. So if I look at there's two different behavior trees going on here. There is one for the medic, and this medic is he's listening for an event to be sent, saying, let's see, need assistance. When the need assistance event is sent, it adds it to a game object list, so the medic knows which agents need assistance. And then as soon as there are there are values within this need assistance list, the agent will select the first one from the list and then seek towards it. And then you can see this branch, this task is currently active. There's a lot going on here. Looks like there's 5 different tasks here, but it will, basically it's just playing an animation and then removing the game object from the list. And then from there, he is sending an event back to the downed game object saying you're healed. And then that downed game object will say, okay, now I'm going to go back to the destination. And then if this medic has nothing to do, it will wait to, or it will seek to a wait point, which is where he started, and just wait there for a downed agent. And that will only happen at the beginning or the end. So then if I look at the game object or the characters that are rushing the scene, actually, let me go ahead and stop it and then hit play just so we can see it active. We can see we're actually using conditional aborts. We are seeking towards the destination target. And then what's happening here is we're comparing this float health value to 0 and saying if I'm dead, I should play some animation and then I could send help or I should ask for help. And then let's see, this is using the event branches saying as soon as the agent has or the medic has healed me, I'm going to receive this heal event, and then I will basically play a getting up animation and then seek the destination again. So there's no way I selected an agent that is going to get shot. That would be extremely lucky. So yeah, that was a fun one.
That is very, very cool. I'm curious, the event system that you're using is the OPSIV event system?
Yes,
Or
the same
yes.
one that's in UCC, or the
That is
character
very
controller and inventory. So yeah, that's part of the shared directory or the shared package. Let's see, the next one is hide and seek. And this one has some player control in it. So let me go ahead and hit play. We have 3 game objects, or we have 3 agents here. And let's see, it's a relatively basic behavior tree. Well, I say that, yeah, relatively basic. And what's happening is that these agents are basically patrolling through some waypoints, and then if they see the agent in sight, they will start chasing them. There will be an alert icon that appears on the top of their head, and then they will start to chase them. And then if the agent or if the player gets out of the way, or the agent can no longer or is no longer within distance of the player, then they will stop and then go back to patrolling. So let me go ahead and play. So I'm going to be approaching an agent. I think he takes the left generally. Yeah. So he's not going to see me. I'm trying to get to a destination, I think we have a diamond somewhere in this maze. But I will go ahead and get caught. So yeah, he briefly saw me. Then I'm stopped being within distance. It looks like we have some collision issues. But yeah, okay, then he runs into me and then the game restarts. So it's not very dramatic if I get caught. And it's actually pretty hard to kind of not get caught. Actually, let's see if I can do it. But where I'm supposed to, I think I'm going down to the bottom left. Let's see. They saw me briefly. I think I have to go where these agents are.
good luck.
So, yeah, these agents are pretty stupid, but it does show kind of how you would design a basic behavior tree similar to this. Oh, so he briefly saw me in that case, and I think my destination's right up here. Yeah, and then it just restarts. Actually, it restarted me back to the wrong point. So there's another thing I'll get fixed. but yeah, this behavior tree, what I wanted to show here was just kind of the classic pattern that behavior trees use, where there are you kind of alternate behaviors and sequences. So selector sequence, and then another selector sequence, and that's just a very common behavior tree pattern. So that was the purpose of showing this example. Plus, I like this scene with the volumetric light. There's this free or this open source volumetric light asset by Christian that he's released, and so it's just a very good marketing material asset as well, or sample scene. Let's see, melee combat. This one we have two different agents. Oh, actually, wait, this one uses that. I'm looking now at the description. What did I say about hide and seek? How you construct your, yeah, okay. So these are both kind of general structural, how you can kind of design your behavior tree. So in this case, we have two different agents that are fighting each other. They are going to alternate, or there's a probability of either slashing their sword or dodging or getting attacked. So my probability looks like it's kind of low right now because none of the agents have actually attacked. There we go. So, oh, I have a really high health value. Okay. Yeah, I was thinking he should not have died that quickly. Let's see. Let me change the health is 10. Let's see. When do I have him going? Oh, I have the run animation set up. Okay. We had changed the animator controller to have different values, and it doesn't look like my changes got saved. So let me go ahead and change these real quick. Set integer 64. And 65. Okay. Now I will save this. All right. Now when he attacks, we should not see the agent falling over right away. But let's see. Come on. There we go. Come on. Attack. Still isn't attacking. Attack. There we go. We got one attack. So yeah, I think I need to increase the probability that he actually does some attacking. But this is kind of an example using conditional aborts and then the behavior tree structure. There were a few different attack types. This agent can also, instead of taking damage, he can dodge or block. And yeah, so it doesn't look like these are, I need to adjust some probability values, it looks like. But yeah, this is a kind of a common behavior tree setup as well, alternating between selector and sequences. So yeah, that was kind of the purpose of that, and then also to use it for marketing material. Let's see, what's the next one? Persistent scenes. Yes, I do want to say that. So persistent scenes allows you, the behavior tree for this is pretty basic, but what it does allow you, or what it does show, is spawning a behavior tree agent and then having that behavior tree agent persist between different scenes. The behavior tree will stay active. So let me go and hit play, and then I'm going to pause it and then find my behavior tree. Actually, I should have kind of expanded upon this behavior tree a little bit, but the behavior tree stays active when it changes, and then it kind of goes through the motions. And it looks like the behavior tree stays active, but my scene manager did not reload or set the new variables, so that's why those are missing. So one more thing I got to fix. So I'm up to 3 now.
It's going to increase bit by bit, but that's why we do it, right?
Right. Yeah, it can be fixed. Property binding is a fairly basic scene, and what property binding is, it exists in version 1 of Behavior Designer as well. It basically just maps a shared variable to a specific property. So in this case, we have this health shared variable mapped to the value of this health component. And let me show you that real quick. So if I edit this script, and if we look at the health property right here, we can see that it will then update a health value, and all it really does is just make sure it's a valued value, and then it invokes an event if you're interested. But what's happening here is instead of the behavior tree storing the health value, the property or the component is storing the health value, and so the agent is just going to die after he takes 3 different shots. But yeah, so just kind of showing the property mapping feature. Runtime behavior. Okay, this scene was a little bit more involved as well. And for this scene, we wanted to show swapping out subtrees at runtime. So in version 1 of Behavior Designer, there's a behavior tree reference task. And on that behavior tree reference task, you can call, or when the behavior tree loads, it calls get external behavior, or get external trees, get external behaviors, whatever, one of the two. And what we're doing here is we've improved that flow a lot. So if I look at this selector, it's called the subtree reference selector, and it will. Actually, let me go ahead and just edit this script so that we can look at the script so that we can see what it's doing. It uses this index shared variable to determine which tree or subtree should be loaded. And from that index, I will call evaluate subtrees, and it will load the correct subtree. Well, that's very similar to version 1, but what is new is that when I hit this, there's a button that I can hit in the sample scene, and it will call this one method. Let me go ahead and just look at this script real quick to show what it's actually doing. Let's see, fight. Okay, so when the button is pressed, the 2 agents, they're done training and they get a fight. And this method will be called, which is called reevaluate subtree references. Well, now instead of having to kind of set an external behavior tree, and then set it to null. I forgot the exact process. It was sort of convoluted, but you had to set the external behavior property to null. Then you had to set the tree, and then you had to enable it. Well, now this will reevaluate all the subtree references for you without you having to do anything fancy. And so this subtree reference task right here, this subtree reference selector, it will automatically call this evaluate subtrees method when I say reevaluate, and from there it will load whatever subtree you requested. So let me actually show that in action. And we have this agent here who's he's doing some weights and then also doing some speed work. And you can see there's the strength and speed values that he gets. I mean, it's pretty basic. The longer you go, the higher the number goes. But the big thing is, let me look at my behavior tree. So this right now is alternating between the strength work and the speed work. So now when I hit fight, this evaluate subtrees will reevaluate, and we will get a completely new behavior tree. Let me go ahead and hit pause. And so now this behavior tree will fight against the other agent. Oh, it looks like we have some animation alignment issues, but yeah. So yeah, this new behavior tree loads, and if you ignore the alignment issues, these agents are going to alternate between punching and oh, that was a hard punch. Oh, the agent has trained longer than what I normally do, so the value gets higher. But so it only took two kills to do a knockout, or 2 punches to do a knockout. But then we have a negative value, so that also needs to be changed. But yeah. So the purpose of this scene was to just kind of show reevaluating these subtrees, since that has actually been a fairly common question as well. And it just opens up a lot of possibilities. So, for example, if you have, I don't know, a person or a character who can who patrols versus who stands guard. Well, instead of needing two different branches, you could have two completely different subtrees where this patrol functionality is specific to this set, and then this stand guard is specific to this other set, and you can all have it within the same kind of subtree, or subtrees are just scriptable objects. So the same scriptable object.
Since the subtrees are scriptable objects, can you have nested subtrees one into another?
Yes.
So it can go as far as you want.
Yes. You can go as far as you want, and there is protection and checking within Behavior Designer to prevent recursion. So if you have subtree A referencing subtree B, and then subtree B is referencing subtree A, that's an infinite recursion, and there is checking to prevent that from happening, or it will throw an error basically saying that that's not possible. So yeah, you can nest. And actually, that brings up a good point. One of the things on these subtrees, which has been improved, are these things called subtree overrides. And in version 1 of Behavior Designer, these overridden variables, let me just kind of compare. Since I have version 1 of Behavior Designer, let me go ahead and show it. Let's see, behavior tree reference right at the top. Okay, so in the editor has greatly been improved in this. Let's see if I can get them both on the same screen. So in version, you should be able to tell. Version 1 is on the left, version 2 is on the right. Let's see, and get this window up. So the external behaviors, we now have a better list to view it in, and then also these variables. In version 1, you had to specify the name, the type, the value manually. Now this is a lot more automatic, and it's a lot more user-friendly in that it knows the type, it knows the name of the variables just based off of the subtree, and it allows you to specify them through this drop-down instead of needing to manually type the name and the name and the type. So yeah, that part is a lot better in terms of the actual workflow.
Nice.
Let's see. Save load. Oh no. Okay, fine. We'll do subtrees since we're on that topic. So subtrees is this scene I actually probably should have shown first, since this is just a regular subtree that is being referenced within the behavior tree component. So we have this subtree main subtree, and actually, yeah, that's it. What we have here is actually a new task that is very useful, the Iterator. And let me go ahead and hit play. This scene was inspired a bit by, I think it's called Go-Go Town. It was a popular indie game last summer. So it's kind of just resource gathering, and then we're going to go craft. We have some animations we'll leave you to your imagination for him actually crafting, but he just made a hammer there, I think, or a club is what we called, and now he's going over here, and now he's going to make some juice. He's going to press the button, and then we're going to get some juice pop out. But what's actually happening, the more interesting part in the behavior tree, is we are using, let's see, I really had thought, let me click on this. Yeah, we have, okay, I must have kind of changed it at one point, because this part should have been, we should be using another subtree here, but because this part is the same tree. So, okay, so I'll look to see why this isn't happening, but what should be happening is I should have another, let's see, I should have two different behavior tree reference tasks right here, one on the left, one on the right, and they should both be referencing this craft behavior tree subtree. And this craft one uses this iterator node, which is a new node, allowing you to kind of iterate through the different values. So in this case, let me go ahead and hit play. And in this case, we have these two different iterated values, wood and rocks. And so it's going to iterate between first, I'm going to select the wood element, then I'm going to select the rocks element. And so we don't have two different branches. We just have a single branch with this iterator, allowing you to perform the same functionality on both. So if you come from a programming background, it's very similar to kind of iterating through enums or enumerations in this
That's
case.
very nice. I'm wondering, this
Yeah.
iterator, do you have a similar node, but that is random? Because I can imagine that's something people would want, right, with probability weighting.
I do not have a similar node, but I could easily add a random Boolean there and have it randomly select. Or, I mean, that would not be based on priority or probability, or it would be not any, it would not, I guess it wouldn't be a weighted probability, it would just be a random probability, but that would be random. So yeah, that would be easy to do as well. So yeah, that is the subtree scene. Let me go ahead and select Save Load. So Save Load is a new feature in Behavior Designer Pro, allowing you to save and load. And what we did was this sample scene, I think the last time I talked to you, I was saying how we don't have any shooter examples, and shooters are a common behavior tree usage. So I was like, okay, we need a shooter. So I took this fairly basic, what used to be a fairly basic sample scene, and now I actually took some of the assets from version 2 of the character controller. Some of you may remember this corridor. And now we have a save and load. So let me just go ahead and save. I just click save. And this agent is just shooting these agents as they kind of go down the hall. Let's see. So he's also having to reload. That's why there's this gap. But now I had saved it. So now let me hit load, and we're back to the same spot within the behavior tree as before. So this used to not be possible in Behavior Designer 1, but now in version 2, we can save and load, which is a huge feature. And Dots actually made this easier to implement just because of the data separation from the task logic. So yeah, we can save and load in Behavior Designer now.
So in this case, all of the positions of the characters and their animation state and everything is all saved as data inside the Behavior Designer. Is that correct?
No. So what's happening here is the behavior tree data is saved, but it is then I add some extra functionality to the save method that I'm using positions to save the animator state. So that you'll still want to do. You'll want to use like save. What is it? It's save system, some other type of save system for it. And I could definitely see integrating like Easy Save, I think is a popular one, to allow you to save more than just the behavior tree data. Because actually, let me go ahead and look at this script that does the save and load. Let's go ahead and edit script. So when I hit the save button, so from the behavior tree side of things, it's extremely simple. We just say behavior tree save. But from there, now this is where I'm saving all the enemy positions and the states and all that type of stuff. And so that's kind of where having an integration with another save load or save system would be extremely useful. The one thing with this behavior tree is when you're saving it, you can either save it and get a reference to the save data, or you can actually save it to a specific file path, and then it will just say success or failure. So there are two different ways to save, and then you can also specify how much of the variables you want to save. Kind of similar, just the Unity design pattern, you cannot save scene level objects within a project. So that's also why here I am kind of doing some extra restoring of the variables and whatnot. Let's see, so save, now I'm loading it. So like that's why I'm one of the variables that I'm restoring is the target that the agent is currently shooting at. And since that's a game object. So yeah, it stores everything within the behavior tree, and then you're up you're left to do whatever else you want by yourself or using some type of integration.
Yeah, that makes sense. But it's really cool that you can do this now.
Yeah, it's definitely going to be useful. So this one was a completely different style of sample scene in that I wanted to show it being used for 2D since behavior trees don't care which perspective you're in. And behavior trees are also, I've gotten a decent number of questions on how you can do a turn-based game with behavior trees. So this sample scene, I have a turn-based 2D scene where, okay, now I'm going to select which agent I want to attack. I'm going to attack him. Now he's going to select first which, the behavior tree is one single behavior tree. Basically, it's a very simple behavior tree, but it basically says, okay, I am only going to run when you tell me to run, and I will select which agent should attack, and then I will do the attack for that agent. So it's actually, let me go ahead and play. Let's see if we can see it update. Yeah, so we can see it ticked one time when it was the agent's turn. So a little bit of marketing material here with the 2D scene, and then showing how you can actually tick the behavior tree by yourself.
Nice.
Okay, so that was all the sample scenes except this main one of the entity scene. This entity scene uses the Unity entity graphics package, and this Unity entity graphics package, if you have too many entity graphics on the scene or showing at once, Unity will eventually crash. That is related to URP, and so that's why I say it requires Unity 6 because it's been fixed. So I don't want people to expect this sample scene to work in Unity prior to 6 because specifically of that bug, but the behavior tree is the exact same. Let's go ahead and hit play, and what we're going to have in this case is, as soon as I get to play, come on. Okay, so we have a whole lot of different entities on the screen. In this case, we have 1987. These are regular entities, using Unity dots. So this is where the performance comes in. And let me go ahead and just show the hierarchy. I don't have my normal layout here, so I got to add, let's see, entities, hierarchy. So yeah, we have all these different entity agents that these agents spawned using kind of the regular entity spawning. But here's the data associated with the behavior tree, and we can see this particular entity. The swarm is currently swarming. I will be doing a video showing exactly how all this stuff is tied together. But basically, if we look at the behavior tree, we can have, oh, please don't crash, I don't think it's gonna crash. Okay, good. We can have a bunch of different entities using behavior trees, and looks like I have a bug to fix using Unity 6. Okay, well, maybe, actually, let me go ahead and I can show it here. Let's see, samples, prefabs, entity agent. There we go. Okay, so it loaded here. I got to look at what's happening with Unity 6. But yeah, so we have this behavior tree. You'll notice that each node is green, meaning that they all are using the entity system. And so we're just basically checking, saying, is the turret alive using conditional aborts? Conditional aborts are supported using entities, and then there's just basically a random, or if the turret is alive, there's a random, or the agents will swarm around the turret, and then they will randomly determine, oh, I need to charge into the turret and then damage the turret. So this is a kind of a great example of using entities completely without any game objects at all. And I will be doing a lot of videos, I think, kind of focusing on how you can get the most amount of performance using dots and these specific tasks, since yeah, these tasks are a lot more involved compared to the regular tasks. I mean, even okay, 185 lines with a number of comments, yeah, that's not terrible. But if I look at a more basic example, that's not a basic example. Okay, so this one is what, 67 lines with a lot of comments. So yeah, it's more involved, but you get your huge performance benefit. And I'll definitely be doing more videos kind of showing how you work with the entity system and behavior designer.
Very cool.
So that was our sample scenes. I have some bugs to fix, but well, I'll get them all fixed before the release. But yeah, it's a huge difference from what version 1 is, and I'm hoping it helps a lot of people kind of understand how to work with Behavior Designer.
Yeah, it's very exciting because usually the demos are very much what you're looking for, and when you're trying to do something or you have an idea for a game, you look at the demo scenes and you say, "Oh, if
Right,
he can do it in his demo scenes, it means that I can make my game." Right? So as if the demo scenes are showcasing the true value of what I can do, then
right,
that's a
right, right.
difference.
Yeah, yeah, and I wanted to kind of make them focus on specific features. I came up with a feature list first of what I wanted to showcase. Actually, kind of took a playbook from the Ultimate Inventory system and how you have your feature scenes. I wanted to do something very similar, except these demo scenes are using unique assets for a lot of cases. So they took more time, but I think we also wanted to use them for marketing materials, so we were willing to spend that much time. So kind of in terms of behavior designer, where I'm at, when is the release? When is the release? Where this month, I'm confident with this month.
Oh,
I say that, and it was what, 3 or 4 months since the last time, since I said, oh, I would have the sample scenes done in a month. Well, the sample scenes are done. The bugs that I saw, none of them looked too bad to fix. I will be able to fix them today, and then kind of get those fixed. With the documentation is done. The movement pack is what I'm working on right now. That one is very close to being done. And actually, one of the things I'm doing with the movement pack is that's a little bit different. Let's see, we're gonna. I was just working on the sample scene today, so it may change, may not. But one of the things with the movement pack is, let me go ahead and select the Seek one. With the various integrations with Movement Pack, we had specific new tasks for like A-star pathfinding project or nav mesh agent. Well, now we're going to use the exact same task, but I have kind of abstracted it out a bit, so we can select, oh, if you have a nav mesh agent implementation, then you can just select that. Or if you have A-star implementation, you can select that. So it will make maintenance a lot easier between the two different assets or all the different integrations with the movement pack. And so that's kind of one thing the major thing that I'm changing with the movement pack. The other thing is movement pack today includes can see object within distance and can hear object, I think are the two. Well, I was kind of thinking about it some. Those aren't directly related to movement, and hearing or seeing something has nothing to do with movement. What I wanted to do was kind of broaden that a little bit. So in addition to movement pack, we're going to have something called the senses pack, where we have sight, sound. I think I'm going to do smell. And then I could do some other thing. I mean, smell is in gaming, smell is some abstract concept, right? So I could also do like temperature, visibility, like if you're in a shadow or not. So that pack I'm wanting to expand on. I can't decide if I want to release Behavior Designer before this pack is done or not, because I know can see object and can see or within distance, and mainly those two are extremely useful tasks. Well, I have those kind of included in the sample scenes right now that are available for free. So I'm trying to decide if Census Pack should be done before I release or not. But really, it's just movement pack. I have all the tasks done. Just got to work on this demo scene. come up with census pack, may or may not, and then I have to work on the integrations. The integrations will be fairly quick, and then I'm going to do maybe the top 5 or 10 integrations that are out on Behavior Designer 1. Basically, just going to take those tasks and make it into a version for that works with Behavior Designer Pro. It should be extremely quick, and then I will be ready to release. We have some marketing material and whatnot, but Sarah's working on that at the same time I'm working on getting all this stuff done. So we're close. I'm really thinking within the next couple of weeks I may be done, but I don't want to say a date yet. I'm going to wait to say a date until after we have everything done, except maybe a few integrations or whatever, just to be sure that I can be confident with it, but we are very close. And since we're still at the start of February, I'm confident that it will be February, even though February is a somewhat shorter month.
That's very cool. No, it's close. We can see it from the polish of all those demo scenes.
Sure. Yeah, it is. These demo scenes have definitely taken some time, but I'm so glad that I did it, and I think that it'll definitely be a more polished product when you download it and get to play with it, and you should be at a similar quality level actually as what Behavior Designer 1 is. So yeah, I think most of the issues that we saw in the demo scenes were specific to kind of the art assets or something like that. So most of it were not Behavior Designer issues. There was that one in Unity 6 that I got to look to see why it wasn't loading correctly. But yeah, we're very close. Mm-hmm. So yeah.
In terms of nodes that you're going to add, or do you have all the nodes implemented that you're thinking of including, and everything else will be in packs? Or do you have certain nodes that you believe will be implemented at a later date with like a version 2.1? Or
I mean, send me node requests. I have all of them done that I want to do for this initial release, and it's pretty much on par with Behavior Designer 1 for the most part. It's actually, so Behavior Designer 1, we had to manually create all these various different types of nodes, and Behavior Designer 2, actually, let me go ahead and switch back to my screen. I know I've shown this off before, but for example, I don't know, set active. That's a Unity function, and we are using a delegate to kind of create this set action value. So there is no specific task called or set active. It is instead retrieving these values with a reflection, and then when it initializes, it will create a delegate out of it. So it's an extremely fast way to kind of set this active state. And there is no set active task. Actually, let me go ahead and edit this task delegate. If we can see it in view, we can see, okay, that is not actually a, it can't even pull it up. So that is not even a real task. So I should probably just remove this from the menu. This was actually a new feature that I added today to be able to edit, to locate the scripts that are within it.
It makes so useful.
Yeah, this makes sense. Like if you have the seek task, for example, but yeah, no, this delegate reflection is extremely useful, like you were saying, and it prevents you from needing as many manual tasks, and it's up to date with whatever current version you have Unity you're using, whatever current version of assets you have imported into your project as well. So it negates the need in some sense for just kind of a API integration where it's just taking this task method taking this method and calling it a task. So the integrations will be a little bit more involved because they are going to do more than just call a single method, but the integrations won't take too long. So yes, in terms of, are we going to include any more tasks? Probably not, since I have the demo scenes done, but I can definitely add any more kind of specialized tasks if you need them to. But just the way it's set up, you may not even need any tasks.
Yeah, I can see it. That's you can just add some other assets, and the integration is done by default, right? You don't even have to write certain of the integrations yourself, which is very cool.
Right, which also kind of makes marketing a little bit harder to do because I can't say, oh, we're integrated with 20 different assets. But
you can say we're integrated with everything.
Right, exactly, yeah.
In a sense, it's a similar approach to how it works in with bolts, right? If I'm correct.
Yes.
Yes, yeah.
I'm not sure if they used the delegate version of the reflection, but so this delegate version is extremely fast. So yes, it's very similar in terms of using reflection, but I made sure to spend some time that, oh, this is actually a fast version of reflection.
Hmm. That is very cool.
So yeah, that is the behavior designer sample scenes. Does anybody have any questions? I've been sort of monitoring the chat. There hasn't been too much activity, but no, it doesn't look like it. So yeah, we are getting close to having this out.
Exciting. After how long? How long have you been working on
Don't
this
even
asset?
ask. So initial code base was 2019 when I first started the very first version of, oh, I want an ECS version of Behavior Designer. ECS was not to the point it needed to be yet. And then I have really gone hardcore working on this, maybe for the past year and a half of working on it full time. But between 2019 and 2024, 2023, I was working on it off and on as well. So I don't want to know how many hours have been spent on this. There, no code from version 1 was taken for version 2. Some of the obviously design patterns and stuff like that were taken, but it is a completely new asset in that regard.
Mm-hmm. Yeah.
So, and it's going to lead to many things to come. I don't want to say anything yet, but Santiago is working on a new asset using this graphing layer as well. And it's one that I would say its category doesn't exist on the asset store. Do you think?
Yeah, we'll see. It's going to be exciting to see if people are interested or not. We'll see. It's going to be different.
Yeah,
I'm quite excited about it. Yeah.
yeah. I'm looking forward to that one. And anything that uses this graphing layer will also use dots, so you'll get performance by default. Um, so yeah, I guess let's see, no last minute questions. So yeah, everyone, Santiago, do you have anything else?
No, I think we did a good review on everything, and I'm very excited. People are going to be crazy about Behavior Designer Pro, I'm sure.
I think
With how
so.
popular Behavior Designer was, I can imagine it's going to be just as popular, if not more.
Yeah, I'm hoping so. I think you'll be able to get a lot of really cool functionality out of these new features and just the performance by default using dots.
Mhm.
So yeah, well, thank you for joining, Santiago and everyone else. I will probably, yeah, when I submit Behavior Designer Pro, let's do another live stream,
Yeah,
and we'll kind of celebrate the release, and it will be out on the Asset Store for our next Game Dev Insiders, episode 11.
yeah.
The date
I'm
is TBD.
TBD. I'm looking forward to it. Thank you
Yeah,
for having me.
yeah, no, thank you. All right, well, thank you everyone for watching, and until next time.
Yeah. Bye bye, everyone.